Welcome to the AI Engineer's Guide for LangChain. This is a full course that will take you from the assumption that you know nothing about LangChain to being able to proficiently use the framework either within LangChain, within LangGraph, or even elsewhere from the fundamentals that you will learn in this course. Now, this course will be broken up into multiple chapters. We're going to start by talking a little bit about what LangChain is and when we should really be using it and when maybe we don't want to use it. And we'll talk about the pros and cons and also about the wider LangChain ecosystem, not just about the LangChain framework itself. From there, we'll introduce LangChain. We'll just have a look at a few examples before diving into essentially the basics of the framework. Now, I will just note that all of this is for LangChain 0.3. So that is the latest current version. Although that being said, we will cover a little bit of where LangChain comes from as well. So we'll be looking at pre 0.3 version methods for doing things so that we can understand, okay, that's the old way of doing things. How do we do it now that we're in version 0.3? And also, how do we dive a little deeper into those methods as well and kind of customize those? From there, we'll be diving into what I believe is the sort of future of AI. I mean, it's the now and the short term, potentially even further into the future. And that is agents. We'll be spending a lot of time on agents. So we'll be starting with a simple introduction to agents. So that is, how can we build an agent that is simple? What are the main components of agents? What do they look like? And then we'll be diving much deeper into them, and we'll be building out our own agent executor, which is kind of like the framework around the AI components of an agent. We're building our own. And once we've done our deep dive on agents, we'll be diving into LangChain expression language, which we'll be using throughout this course. So LangChain expression language is the sort of recommended way of using LangChain, and the expression language, or LSL, takes kind of like a break from standard Python syntax. So there's a bit of weirdness in there. And yes, we'll be using it throughout the course, but we're leaving the LSL chapter until this, kind of later on in the course, because we really want to dive into the fundamentals of LSL by that point. But the idea is that by this point, you already have a good grasp of at least how to use the basics of LSL before we really dig in at that point. Then we'll be digging into streaming, which is an essential UX feature of AI applications in general. Streaming, it can just improve the user experience massively. And it's not just about streaming tokens, that interface where you have word by word, the AI is generating text on the screen. Streaming is more than just that. It is also the ability, if you've seen the interface of Perplexity, where as the agent is thinking, you're getting an update of what the agent is thinking about, what tools it is using, and how it is using those tools. That's also another essential feature that we need to have a good understanding of streaming to build. So we'll also be taking a look at all of that. Then we'll be topping it off with a capstone project where we will be building our own AI agent application that is going to incorporate all of these features. We're going to have an agent that can use tools, web search. We'll be using streaming, and we'll see all of this in a nice interface that we can work with. So that's an overview of the course. Of course, it's very high level, what I've just gone through. There's a ton of stuff in here. And truly, this course can take you from, wherever you are with LangChain at the moment, and whether you're a beginner or you've used it a bit or even intermediate, and you're probably going to learn a fair bit from it. So without any further ado, let's dive into the first chapter. Okay, so the first chapter of the course, we're going to focus on when should we actually use LangChain and when should we use something else. Now, through this chapter, we're not really going to focus too much on the code. Every other chapter is very code focused, but this one is a little more just theoretical. What is LangChain? Where does it fit in? When should I use it? When should I not? So I want to just start by framing this. LangChain is one of, if not the most popular open source framework within the Python ecosystem, at least for AI. It works pretty well for a lot of things and also works terribly for a lot of things as well, to be completely honest. There are massive pros, massive cons to using LangChain. Here, we're just going to discuss a few of those and see how LangChain maybe compares a little bit against other frameworks. So the very first question we should be asking ourselves is, do we even need a framework? Is a framework actually needed when we can just hit an API? You have the OpenAI API, other APIs, Mistral, so on, and we can get a response from an LLM in 5 lines of code on average for those. It's incredibly, incredibly simple. However, that can change very quickly when we start talking about agents or retrieval augmented generation, research assistants, all of this sort of stuff. Those use cases, those methods can suddenly get quite complicated when we're outside of frameworks. And that's not necessarily a bad thing, right? It can be incredibly useful to be able to just understand everything that is going on and build it yourself. But the problem is that to do that, you need time. Like, you need to learn all the intricacies of building these things, the intricacies of these methods themselves, like how do they even work? And that kind of runs in the opposite direction of what we see with AI at the moment, which is AI is being integrated into the world at an incredibly fast rate. And because of this, most engineers coming into the space are not from a machine learning or AI background. Most people don't necessarily have any experience with these systems. A lot of engineers coming in that could be DevOps engineers, generic backend Python engineers, even front-end engineers coming in and building all these things, which is great, but they don't necessarily have the experience. And that might be you as well. And that's not a bad thing, because the idea is that obviously you're going to learn and you're going to pick up a lot of these things. And in this scenario, there's quite a good argument for using a framework, because a framework means that you can get started faster. And a framework like LangChain, it abstracts away a lot of stuff. And that's a big complaint that a lot of people will have with LangChain. But that abstracting away of many things is also what makes LangChain popular, because it means that you can come in not really knowing, okay, what RAG is, for example, and you can implement a RAG pipeline, get the benefits of it without really needing to understand it. And yes, there's an argument against that as well, just implementing something without really understanding it. But as we'll see throughout the course, it is possible to work with LangChain in a way, as we will in this course, where you kind of implement these things in an abstract way and then break them apart and start understanding the intricacies at least a little bit. So that can actually be pretty good. However, again, circling back to what we said at the start, if the idea or your application is just a very simple, you need to generate some text based on some basic input, maybe you should just use an API. That's completely valid as well. Now, we just said, okay, a lot of people coming to LangChain might not be from an AI background. So another question for a lot of these engineers might be, okay, if I want to learn about RAG, agents, all of these things, should I skip LangChain and just try and build it from scratch myself? Well, LangChain can help a lot with that learning journey. So you can start very abstract. And as you gradually begin to understand the framework better, you can strip away more and more of those abstractions and get more into the details. And in my opinion, this gradual shift towards more explicit code with less abstraction is a really nice feature. And it's also what we focus on, right? Throughout this course, that's what we're going to be doing. We're going to be starting abstract, stripping away the abstractions, and getting more explicit with what we're building. So, for example, building an agent. In LangChain, there's in this very simple and incredibly abstract create tools agent method that we can use. And it creates a tool agent for you. It doesn't tell you anything. So you can use that, right? And we will use that initially in the course, but then you can actually go from that to defining your full agent execution logic, which is basically a tool's call to OpenAI, You're going to be getting that tool information back, but then you've got to figure out, okay, how am I going to execute that? How am I going to store this information? And then how am I going to iterate through this? So we're going to be seeing that stripping away of abstractions as we work through, as we build agents, as we build like our streaming use case, among many other things, even chat memory. We'll see there as well. So LangChain can act as the on-ramp to your AI learning experience. Then what you might find, and I do think this is quite true for most people, is that if you're really serious about AI engineering and that's what you want to do, like that's your focus, right? Which isn't for everyone, for certain. A lot of people just want to understand a bit of AI and they want to continue doing what they're doing and just integrate AI here and there. And maybe those, if that's your focus, you might stick with LangChain. There's not necessarily a reason to move on. But in the other scenario where you're thinking, okay, I want to get really good at this, I want to just learn as much as I can, and I'm going to dedicate basically my short-term future of my career on becoming AI engineer, then LangChain might be the on-ramp, it might be your initial learning curve, but then after you've become competent with LangChain, you might actually find that you want to move on to other frameworks. And that doesn't necessarily mean that you're going to have wasted your time with LangChain, because one, LangChain is a thing helping you learn, and two, one of the main frameworks that I recommend a lot of people to move on to is actually LangGraph, which is still within the LangChain ecosystem, and it still uses a lot of LangChain objects and methods, and of course concepts as well. So even if you do move on from LangChain, you may move on to something like LangGraph, which you can know LangChain for anyway. And let's say you do move on to another framework instead. In that scenario, the concepts that you learn from LangChain are still pretty important. So to just finish up this chapter, I just want to summarize on that question of should you be using LangChain? What's important to remember is that LangChain does abstract a lot. Now, this abstraction of LangChain is both a strength and a weakness. With more experience, those abstractions can feel like a limitation. And that is why we sort of go with the idea that LangChain is really good to get started with. But as the project grows in complexity or the engineers get more experience, they might move on to something like LangGraph, which in any case is going to be using LangChain to some degree. So in either one of those scenarios, LangChain is going to be a core tool in an AI engineer's toolkit. So it's worth learning, in our opinion. But of course, it comes with its weaknesses, and it's just good to be aware of that. It's not a perfect framework, but for the most part, you will learn a lot from it, and you will be able to build a lot with it. So with all of that, we'll move on to our first sort of hands-on chapter with LangChain, where we'll just introduce LangChain, some of the essential concepts. We're not going to dive too much into the syntax, but we're just going to understand a little bit of what we can do with it. Okay, so moving on to our next chapter, getting started with LangChain. In this chapter, we're going to be introducing LangChain by building a simple LLM-powered assistant that will do various things for us. It will be multimodal, generating some text, generating images, generate some structured output. It will do a few things. Now, to get started, we will go over to the course repo. All of the code, all the chapters are in here. There are two ways of running this, either locally or in Google Colab. We would recommend running in Google Colab because it's just a lot simpler with environments, but you can also run it locally. And actually for the capstone, we will be running it locally. There's no way of us doing that in Colab. So if you would like to run everything locally, I'll show you how quickly now. If you would like to run in Colab, which I would recommend at least for the first notebook chapters, just skip ahead. There will be chapter points in the timeline of the video. So for running it locally, we just come down to here. So this actually tells you everything that you need. So you will need to install UV. Right, so this is the package manager that we recommend by the Python and package management library. You don't need to use UV, it's up to you. UV is very simple, it works really well. So I would recommend that. So you would install it with this command here. This is on Mac, so it will be different otherwise. If you are on Windows or otherwise, you can look at the installation guide there and it'll tell you what to do. And so before we actually do this, what I will do is go ahead and just clone this repo. So we'll come into here. I'm going to create like a temp directory for me because I already have the LangChain course in there. And what I'm going to do is just git clone LangChain course. Okay, so you will also need to install Git if you don't have that. Okay, so we have that. Then what we'll do is copy this. Okay, so this will install Python 3.12.7 for us with this command. Then this will create a new venv within that or using Python 3.12.7 that we've installed. And then uvsync will actually be looking at the pyproject.toml file. That's like the package installation for the repo, and using that to install everything that we need. Now, we should actually make sure that we are within the LangChain course directory. And then yes, we can run those three. And there we go. So everything should install with that. Now, if you are in Cursor, you can just do cursor dot, or we can run code dot. If in VS Code, I would just be running this. And then I've opened up the course. Now within that course, you have your notebooks, and then you just run through these, making sure you select your kernel, Python environment, and making sure you're using the correct venv from here. So that should pop up already as this venv bin Python, and you'll click that, and then you can run through. When you are running locally, don't run these. You don't need to. You've already installed everything. So you don't, this specifically is for Colab. So that is running things locally. Now let's have a look at running things in Colab. So for running everything in Colab, we have our notebooks in here. We click through, and then we have each of the chapters through here. So starting with the first chapter, the introduction, which is where we are now. So what you can do to open this in Colab is either just click this Colab button here, or if you really want to, for example, maybe this is not loading for you, what you can do is you can copy the URL at the top here. You can go over to Colab, you can go to Open, GitHub, and then just paste that in there and press Enter. And there we go. We have our notebook. Okay, so we're in now. What we will do first is just install the prerequisites. So we have LangChain, just a load of LangChain packages here, LangChain Core, LangChain OpenAI, because we're using OpenAI, and LangChain Community, which is needed for running what we're running. Okay, so that has installed everything for us. So we can move on to our first step, which is initializing our LLM. So we're going to be using GPT-4o Mini, which is like a small but fast, but also cheaper model. That is also very good from OpenAI. So what we need to do here is get an API key. Okay, so for getting that API key, we're going to go to OpenAI's website. And you can see here that we're opening platform.openai.com, and then we're going to go into settings, organization, API keys. So you can copy that or just click it from here. Okay, so I'm going to go ahead and create a new secret key. Actually, just in case you're kind of looking for where this is, it's settings, organization, API keys again. Okay, create a new API key. I'm going to call it LangChain course. I'll just put it under semantic router. That's just my organization. You put it wherever you want it to be. And then you would copy your API key. You can see mine here. I'm obviously going to revert that before you see this, but you can try and use it if you really like. So I'm going to copy that, and I'm going to place it into this little box here. You could also just place it, put your full API key in here. It's up to you, but this little box just makes things easier. Now, what we've basically done there is just pass in our API key. We're setting our OpenAI model, GPT-4o Mini. And what we're going to be doing now is essentially just connecting and setting up our LLM parameters with LangChain. So we run that. We say, okay, we're using a GPT-4o Mini, and we're also setting ourselves up to use 2 different LLMs here, or 2 of the same LLM with slightly different settings. So the first of those is an LLM with a temperature setting of 0. The temperature setting basically controls almost the randomness of the output of your LLM. And the way that it works is when an LLM is predicting the sort of next token or next word in sequence, it'll provide a probability actually for all of the tokens within the LLM's knowledge base, or what the LLM has been trained on. So what we do when we set a temperature of 0 is we say, you are going to give us the token with highest probability according to you, okay? Whereas when we set a temperature of 0.9, what we're saying is, okay, there's actually an increased probability of you giving us a token that, according to your generated output, is not the token with the highest probability according to the LLM. But what that tends to do is give us more sort of creative outputs. So that's what the temperature does. So we are creating a normal LLM and then a more creative LLM with this. So what are we going to be building? We're going to be taking a article draft. So like a draft article from the Aurelio learning page. And we're going to be using LangChain to generate various things that we might find helpful as we have this article draft and we're editing it and just kind of like finalizing it. So what are those going to be? You can see them here. We have the title for the article, the description, an SEO friendly description specifically. The third one, we're going to be getting the LLM to provide us advice on an existing paragraph and essentially writing a new paragraph for us from that existing paragraph. And what it's going to do, this is the structured output part, is it's going to write a new version of that paragraph for us, and it's going to give us advice on where we can improve our writing. Then we're going to generate a thumbnail or hero image for our article. So nice image that you would put at the top. So here, we're just going to input our article. You can put something else in here if you like. Essentially, this is just a big article that's written a little while back on agents. And now we can go ahead and start preparing our prompts, which are essentially the instructions for our LLM. So LangChain comes with a lot of different like utilities for prompts, and we're going to dive into them in a lot more detail, but I do want to just give you the essentials now, just so you can understand what we're looking at least conceptually. So prompts for chat agents are at a minimum broken up into 3 components. Those are the system prompt. This provides instructions to our LM on how it should behave, what its objective is, and how it should go about achieving that objective. Generally, system prompts are going to be a bit longer than what we have here, depending on the use case. Then we have our user prompts. So these are user written messages. Usually, sometimes we might want to pre-populate those if we want to encourage a particular type of conversational patterns from our agent. But for the most part, yes, these are going to be user generated. Then we have our AI prompts. So these are, of course, AI generated. And again, in some cases, we might want to generate those ourselves beforehand or within a conversation if we have a particular reason for doing so. But for the most part, you can assume that these are actually user and AI generated. Now, LangChain provides us with templates for each one of these prompt types. Let's go ahead and have a look at what these look like within LangChain. So to begin, we are looking at this one. So we have our system message prompt template and human message, which is the user that we saw before. So we have these 2. System prompt, keeping it quite simple here. You are an AI system that helps generate article titles, right? So our first component where we want to generate is article title. So we're telling the AI, that's what we want it to do. And then here, right? So here we're actually providing kind of like a template for a user input. So yes, as I mentioned, user input can be, it can be fully generated by a user. It might be kind of not generated by a user. It might be setting up a conversation beforehand, which then a user would later use. Or in this scenario, we're actually creating a template, and what the user will provide us will actually just be inserted here inside article. And that's why we have this import variables. So what this is going to do is, okay, we have all of these instructions around here. They're all going to be provided to OpenAI as if it is the user saying this. But it will actually just be this here that a user will be providing. Okay, and we might want to also format this a little nicer. It kind of depends. This will work as it is, but we can also put, something like this to make it a little bit clearer to the LLM. Okay, what is the article? Where are the prompts? So we have that. And you can see in this scenario, there's not that much difference between what the system prompt and the user prompt is doing. And it's a particular scenario. It varies. When you get into the more conversational stuff, as we will do later, you'll see that the user prompt is generally more fully user generated or mostly user generated. And much of these types of instructions we might actually be putting into the system prompt. It varies, and we'll see throughout the course many different ways of using these different types of prompts in various different places. Then you'll see here, so I just want to show you how this is working. We can use this format method on our user prompt here to actually insert something within the article input here. So we're going to go user prompt format, and then we pass in something for article. Okay. And we can also maybe format this a little nicer, but I'll just show you this for now. So we have our human message, and then inside the content, this is the text that we had. All right, you can see that we have all of this, right? And this is what we wrote before. We wrote all this except from this part. We didn't write this. Instead of this, we had article. All right. So let's format this a little nicer so we can see. Okay, so this is exactly what we wrote up here. Exactly the same, except from now we have test string instead of article. So later, when we insert our article, it's going to go inside there. That's all it's doing. It's like it's an F string in Python. Okay, and this is one of the things where people might complain about LangChain. This sort of thing can be, it seems excessive because you could just do this with an F string. But there are, as we'll see later, particularly when you're streaming, there's really helpful features that come with using LangChain's kind of built-in prompt templates, or at least message objects that we'll see. So, we need to keep that in mind. Again, as things get more complicated, LangChain can be a bit more useful. So, chat prompt template. This is basically just going to take what we have here, our system prompt, user prompts. You could also include some AI prompts in there. And what it's going to do is merge both of those. And then when we do format, what it's going to do is put both of those together into a chat history. Okay, so let's see what that looks like first in a more messy way. Okay. So you can see we have just the content, right? So it doesn't include the whole, before we had human message, we're not seeing anything like that here. Instead, we're just seeing the string. So now let's switch back to print. And we can see that what we have is our system message here. It's just prefixed with this system. And then we have human, and it's prefixed by human, and then it continues. Right, so that's all it's doing. It's just kind of merging those in some sort of chat log. We could also put in like AI messages, and they would appear in there as well. Okay, so we have that. Now that is our prompt template. Let's put that together with an LLM to create what would be in past LangChain be called an LLM chain. Now we wouldn't necessarily call it an LLM chain because we're not using that LLM chain abstraction. It's not super important if that doesn't make sense. We'll go into it in more detail later, particularly in the LSOL chapter. So what this chain will do, think LangChain is just chains where we're chaining together these multiple components. It will perform the steps prompt formatting. So that's what I just showed you. LLM generation, so sending our prompt to OpenAI, getting a response, and getting that output. So you can also add another step here if you want to format that in a particular way. We're going to be outputting that in a particular format so that we can feed it into the next step more easily. But there are also things called output parsers, which parse you're outputting a more dynamic or complicated way depending on what you're doing. So this is our first look at LSL. I don't want us to focus too much on the syntax here because we will be doing that later, but I do want you to just understand what is actually happening here and logically what are we writing. So all we really need to know right now is we define our inputs with the first dictionary segment here, right? So this is our inputs, which we have defined already, okay? So if we come up to our user prompt here, we said the input variable is our article, right? And we might have also added input variables to the system prompt here as well. In that case, let's say we had you're an AI assistant called name, right? That helps generate article titles. In this scenario, we might have an input variables name here, right? And then what we would have to do down here is we would also have to pass that in, right? So we would have article, but we would also have name. So basically, we just need to make sure that in here we're including the variables that we have defined as input variables for our first prompts. Okay, so we can actually go ahead and let's add that so we can see it's in action. So we'll run this again and just include that or reinitialize our first prompt. So we see that. And if we just have a look at what that means for this format function here, it means we'll also need to pass in a name. Okay, and call it Joe. Okay, so Joe the AI, right? So you are an AI assistant called Joe now. Okay, so we have Joe, our AI, that is going to be fed in through these input variables. Then we have this pipe operator. The pipe operator is basically saying whatever is to the left of the pipe operator, which in this case would be this, is going to go into whatever is on the right of the pipe operator. It's that simple. Again, we'll dive into this and kind of break it apart in the LSL chapter, but for now, that's all we need to know. So this is going to go into our first prompt. That is going to format everything. It's going to add the name and the article that we provided into our first prompt. And then it's going to output that, right? It's going to output that. We have our pipe operator here. So the output of this is going to go into the input of our next step. It's our creative LLM. Then that is going to generate some tokens. It's going to generate our output. That output is going to be an AI message. And as you saw before, if I take this bit out, within those message objects, we have this content field, okay? So we are actually going to extract the content field out from our AI message to just get the content. And that is what we do here. So we get the AI message out from our LLM, and then we're extracting the content from that AI message object, and we're going to passing it into a dictionary that just contains article title, like so, okay? We don't need to do that. We can just get the AI message directly. I just want to show you how we are using this sort of chain in LSL. So once we have set up our chain, we then call it or execute it using the invoke method. Into that, we will need to pass in those variables. So we have our article already, but we also gave our AI a name now. So let's add that and we'll run this. Okay, so Joe has generated us a article title, Unlocking the Future, the Rise of Neurosymbolic AI Agents. Cool, much better name than what I gave that article, which was AI Agents are Neurosymbolic Systems. No, I don't think I did too bad. Okay, so we have that. Now, let's continue, and what we're going to be doing is building more of these types of LLM chain pipelines where we're feeding in some prompts, we're generating something, getting something, and doing something with it. So, as mentioned, we have the title. We're now moving on to the description. So we're going to generate a description. So we have our human message prompt template. So this is actually going to go into a similar format as before. We probably also want to redefine this because I think I'm using the same system message there. So let's go ahead and modify that. Or what we could also do is let's just remove the name now because I've shown you that. So what we could do is you're an AI assistant that helps build good articles, right? Build good articles. And we could just use this as our, generic system prompt now. So let's say that's our new system prompt. Now we have our user prompt. You're tasked with creating a description for the article. The article is here for you to examine. Article. Here is the article title. Okay, so we need the article title now as well in our input variables. And then we're going to output an SEO-friendly article description. And we're just saying, just to be certain here, do not output anything other than the description. So, sometimes an LLM might say, hey, look, this is what I've generated for you. The reason I think this is good is because so on and so on and so on, right? If you're programmatically taking some output from an LLM, you don't want all of that fluff around what the LLM has generated. You just want exactly what you've asked it for, okay? Because otherwise you need to parse out with code and it can get messy and also just far less reliable. So we're just saying, don't output anything else. Then we're putting all of these together. So system prompt and the second user prompt, this one here. Putting those together into a new chat prompt template. And then we're going to feed all of that in to another LSL chain as we have here to generate our description. So let's go ahead. We invoke that as before. We're just making sure we add in the article title that we got from before. And let's see what we get. Okay, so we have this. Explore the transformative potential of neurosymbolic AI agents in a little bit long, to be honest. But yeah, you can see what it's doing here, right? And of course, we could then go in, we see this is kind of too long. We're like, SEO-friendly description, not really. So we can modify this. Output the SEO-friendly description. Make sure we don't exceed, let me put that in a new line. Make sure we don't exceed, say, 200 characters, or maybe it's even less for SEO. I don't have a clue. I'll just say 120 characters. Do not output anything other than the description, right? So we could just, go back, modify our prompting, see what that generates again. Okay, so much shorter, probably too short now, but that's fine. Cool. So we have that. We have a summary, process that, and that's now, in this dictionary format that we have here. Cool. Now the third step, we want to consume that first article variable with our full article. And we're going to generate a few different output fields. So for this, we're going to be using the structured output feature. So let's scroll down. We'll see what that is or what that looks like. So structured output is essentially we're forcing the LLM, like it has to output a dictionary with these, particular fields. Okay. And we can modify this quite a bit, but in this scenario, what I want to do is I want there to be an original paragraph, right? So I just want it to regenerate the original paragraph because I'm lazy and I don't want to extract it out. Then I want to get the new edited paragraph. This is the LLM generated improved paragraph. And then we want to get some feedback because we don't want to just automate ourselves. We want to augment ourselves and get better with AI rather than just being like, you do this. So that's what we do here. And you can see that here we're using this Pydantic object. And what Pydantic allows us to do is define these particular fields. And it also allows us to assign these descriptions to a field. And LangChain is actually going to go ahead, read all of this, right? Even reads, so for example, we could put integer here and we could actually get a numeric score for our paragraph. Right, and we can try that, right? So let's just try that quickly. I'll show you. So numeric score. In fact, let's even just ignore. Let's not put anything here. So I'm going to put constructive feedback on the original paragraph, but I just put int here. So let's see what happens. Okay. So we have that. And what I'm going to do is I'm going to get our creative LLM. I'm going to use this with structured output method, and that's actually going to modify that LLM class, create a new LLM class that forces that LLM to use this structure for the output, right? So passing in paragraph into here. Using this, we're creating this new structured LLM. So let's run that and see what happens, okay? So we're going to modify our chain accordingly. Maybe what I can do is also just remove this bit for now, so we can just see what the structured LLM outputs directly. And let's see. Okay, so now you can see that we actually have that paragraph object, right? The one we defined up here, which is kind of cool. And then in there, we have the original paragraph. right? So this is where this is coming from. I definitely remember writing something that looks a lot like that. So I think that is correct. We have the edited paragraph. So this is, okay, what it thinks is better. And then interestingly, the feedback is 3, which is weird, right? Because here we said the constructive feedback on the original paragraph. But what we're doing when we use this with structured output, or what LangChain is doing, is essentially performing a tool call to OpenAI. And what a tool call can do is force a particular structure in the output of an LLM. So when we say feedback has to be an integer, no matter what we put here, it's going to give us an integer. Because how do you provide constructive feedback with an integer? It doesn't really make sense. But because we've set that limitation, that restriction here, that is what it does. It just gives us the numeric value. So I'm going to shift that to string, and then let's rerun this, see what we get. Okay, we should now see that we actually do get constructive feedback. All right, so yeah, we can see it's quite long. So the original paragraph effectively communicates the limitations of neural AI systems in performing certain tasks. However, it could benefit from slightly improved clarity and conciseness. For example, the phrase "was becoming clear" can be made more direct by changing it to "became evident." Well, yeah, true. Thank you very much. So yeah, now we actually get that feedback, which is pretty nice. Now let's add in this final step to our chain. Okay, and it's just going to pull out our paragraph object here and extracting to a dictionary. We don't necessarily need to do this. Honestly, I actually kind of prefer it within this paragraph object, but just so we can see how we would parse things on the other side of the chain. Okay, so now we can see we've extracted that out. Cool, so we have all of that. Interesting feedback again, but let's leave it there for the text part of this. Now let's have a look at the sort of multimodal features that we can work with. So this is, maybe one of those things that's kind of seems a bit more abstracted, a little bit complicated, where it maybe could be improved, but, we're not going to really be focusing too much on the multimodal stuff. We'll instead be focusing on language, but I did want to just show you very quickly. So we want this article to look better, okay? We want to generate a prompt based on the article itself that we can then pass to DALL-E, the image generation model from OpenAI, that will then generate an image, like a thumbnail image for us. Okay, so the first step of that is we're actually going to get an LLM to generate that. All right, so we have our prompt that we're going to use for that. So I'm going to say generate a prompt with less than 500 characters to generate an image based on the following article. Okay, so that's our prompt. Yeah, super simple. We're using the generic prompt template here. You can use that. You can use user prompt template. It's up to you. This is just like the generic prompt template. Then what we're going to be doing is, based on what this outputs, we're then going to feed that in to this generate and display image function via the image prompt parameter. That is going to use the DALL-E API wrapper from LangChain. It's going to run that image prompt, and we're going to get a URL out from that, essentially. And then we're going to read that using skimage here. Right, so we're just going to read that image URL, going to get the image data, and then we're just going to display it. Okay, so pretty straightforward. Now, again, this is a LCell thing here that we're doing, and we have this runnable Lambda thing. When we're running functions within LCell, we need to wrap them within this runnable Lambda. I don't want to go too much into what this is doing here because we do cover it in the LCell chapter. But it's just, all you really need to know is we have a custom function, wrap it in runnable Lambda, and then what we get from that we can use within this here, right? The LCell syntax. So what are we doing here? Let's figure this out. We are taking our original, that image prompt that we defined just up here, right? Input variable to that is article, okay? We have our article data being input here, feeding that into our prompt. From there, we get our message that we then feed into our LLM. From the LLM, it's going to generate us an image prompt, like a prompt for generating our image for this article. We can even, let's print that out. so that we can see what it generates, because I'm also kind of curious. Okay, so we'll just run that. And then let's see, it will feed in that content into our runnable, which is basically this function here. And we'll see what it generates. Okay, don't expect anything amazing from DALL-E. It's not the best, to be honest, but at least we see how to use it. Okay, so we can see the prompt that was used here. Create an image that visually represents the concept of neurosymbolic agents, depict a futuristic interface where large language model interacts with traditional code, symbolizing integration of, oh my gosh, something computation, include elements like a brain to represent neural networks, gears or circuits or symbolic logic, and a web of connections illustrating vast use cases of AI agents. Oh my gosh, look at all that. Big prompt. Then we get this. So, DALL-E is interesting, I would say. We could even take this. Let's just see what that comes up with in something like Midjourney. You can see these way cooler images that we get from just another image generation model. Far better, but pretty cool, honestly. So in terms of generation, images, the phrasing, the prompt itself is actually pretty good. The image, it could be better, but that's it, right? So with all of that, we've seen a little introduction to what we might be building with LangChain. So that's it for our introduction chapter. As I mentioned, we don't want to go too much into what each of these things is doing. I just really want to focus on, okay, this is kind of how we're building something with LangChain. This is the overall flow, but we don't really want to be focusing too much on, okay, what exactly LSL is doing, or what exactly this prompt thing is that we're setting up. We're going to be focusing much more on all of those things and much more in the upcoming chapters. So for now, we've just seen a little bit of what we can build before diving in more detail. Okay, so now we're going to take a look at AI observability using Langsmith. Now, Langsmith is another piece of the broader LangChain ecosystem. Its focus is on allowing us to see what our LLMs, agents, etc. are actually doing. And it's something that we would definitely recommend using if you are going to be using LangChain and LangGraph. Now let's take a look at how we would set Langsmith up, which is incredibly simple. So I'm going to open this in Colab, and I'm just going to install the prerequisites here. You'll see these are all the same as before, but we now have the Langsmith library here as well. Now, we are going to be using Langsmith throughout the course. So in all the following chapters, we're going to be importing Langsmith, and that will be tracking everything we're doing. But you don't need Langsmith to go through the course. It's an optional dependency. But as mentioned, I would recommend it. So we'll come down to here, and first thing that we will need is the LangChain API key. Now, we do need an API key, but that does come with a reasonable free tier. So we can see here, they have each of the plans, and this is the one that we are by default on. So it's free for one user up to 5,000 traces per month. If you're building out an application, I think it's fairly easy to go beyond that, but it really depends on what you're building. So it's a good place to start with. And then of course you can upgrade as required. So we would go to smith.langchain.com, and you can see here that this will log me in automatically. I have all of these tracing projects. These are all from me running the various chapters of the course. Yours, if you do use Langsmith throughout the course, your Langsmith dashboard will end up looking something like this. Now, what we need is an API key. So we go over to settings, we have API keys, and we're just going to create an API key. Because we're just going through some personal learning right now, I would go with personal access token. We can give a name or description if you want. Okay, and we'll just copy that. And then we come over to our notebook and we enter our API key there. And that is all we actually need to do. That's absolutely everything. I suppose the one thing to be aware of is that you should set your LangChain project to whatever project you're working within. So of course, within the course, we have individual project names for each chapter, but for your own projects, of course, you should make sure this is something that you recognize and is useful to you. So Langsmith actually does a lot without us needing to do anything. So we can actually go through, let's just initialize our LLM and start invoking it and seeing what Langsmith returns to us. So we'll need our OpenAI API key, enter it here, and then let's just invoke hello. Okay, so nothing has changed on this end, right? So us running code, there's nothing different here. However, now if we go to Langsmith, I'm going to go back to my dashboard. Okay, and you can see that the order of these projects just changed a little bit. And that's because the most recently used project, i.e. this one at the top, LangChain course Langsmith OpenAI, which is the current chapter we're in, that was just triggered. So I can go into here and I can see, oh, look at this. So we actually have something in the Langsmith UI, and all we did was enter our LangChain API key. That's all we did. And we set some environment variables. And that's it. So we can actually click through to this and it will give us more information. So you can see what was the input, what was the output, and some other metadata here. You see, there's not that much in here. However, when we do the same for agents, we'll get a lot more information. So I can even show you a quick example from the future chapters. If we come through to agents intro here, for example, and we just take a look at one of these. Okay, so we have this input and output, but then on the left here, we get all of this information. And the reason we get all this information is because agents they're performing multiple LLM calls, etc., etc. So there's a lot more going on. So we can see, okay, what is the first LLM call? And then we get these tool use traces. We get another LLM call, another tool use, and another LLM call. So you can see all this information, which is incredibly useful and incredibly easy to do, because all I did when setting this up in that agents chapter was simply set the API key and the environment variables as we have done just now. So you get a lot out of very little effort with Langsmith, which is great. So let's return to our Langsmith project here and let's invoke some more. Now, I've already shown you, we're going to see a lot of things just by default, but we can also add other things that Langsmith wouldn't typically trace. So to do that, we will just import the traceable decorator from Langsmith. And then let's make these just random functions traceable within Langsmith. Okay, so we'll run those. We have 3 here, so we're going to generate a random number. We're going to modify how long a function takes and also generate a random number. And then in this one, we're going to either return this no error or we're going to raise an error. So we're going to see how Langsmith handles these different scenarios. So let's just iterate through and run those a few times. So we're just going to run each one of those 10 times. Okay, so let's see what happens. So they're running. Let's go over to our Langsmith UI and see what is happening over here. So we can see that everything is updating. We're getting that information through. And we can see if we go into a couple of these, we can see a little more information. So the input and the output took 3 seconds. See random error here. In this scenario, random error passed without any issues. Let me just refresh the page quickly. Okay, so now we have the rest of that information. And we can see that occasionally, if there is an error from our random error function, it is signified with this. And we can see the traceback as well that was returned there, which is useful. Okay, so we can see if an error has been raised, we'll be able to see what that error is. We can see the various latencies of these functions. So you can see that varying throughout here. We see all the inputs to each one of our functions and then, of course, the outputs. So we can see a lot in there, which is pretty good. Now, another thing that we can do is we can actually filter. So if we come to here, we can add a filter. Let's filter for errors. That would be value error. And then we just get all of the cases where one of our functions has returned or raised an error or a value error specifically. Okay, so that's useful. And then, yeah, there's various other filters that we can add there. So we could add a name, for example, if we wanted to look for the generate string delay function only. We could also do that. Okay, and then we can see the varying latencies of that function as well. Cool, so we have that. Now, one final thing that we might want to do is maybe we want to make those function names a bit more descriptive or easy to search for example. And we could do that by saying the name of the traceable decorator, like so. So let's run that. We'll run this a few times. And then let's jump over to Langsmith again. Go into Langsmith project. Okay, and you can see those coming through as well. So then we could also search for those based on that new name. So what was it? Chit Chat Maker, like so. And then we can see all that information being streamed through to Langsmith. So that is our introduction to Langsmith. There is really not all that much to go through here. It's very easy to set up, and as we've seen, it gives us a lot of observability into what we are building. And we will be using this throughout the course. We don't rely on it too much. It's a completely optional dependency, so if you don't want to use Langsmith, you don't need to. But it's there, and I would recommend doing so. So that's it for this chapter. We'll move on to the next one. Now we're going to move on to the chapter on prompts in LangChain. Now, prompts, they seem like a simple concept, and they are a simple concept, but there's actually quite a lot to them when you start diving into them. And they truly have been a very fundamental part of what has propelled us forwards from sort of pre-LLM times to the current LLM times. You have to think, until LLMs became widespread, the way to fine-tune a AI model or ML model back then was to get loads of data for your particular use case, spend a load of training your specific transformer or part of the transformer to essentially adapt it for that particular task. That could take a long time. Depending on the task, it could take you, months, or in some times, if it was a simpler task, it might take probably days, potentially weeks. Now, the interesting thing with LLMs is that rather than needing to go through this whole fine-tuning process to modify a model for one task over another task, rather than doing that, we just prompt it differently. We literally tell the model, hey, I want you to do this in this particular way. And that is that's a paradigm shift in what you're doing. It's so much faster. It's going to take you, a couple of minutes rather than days, weeks, or months. And LLMs are incredibly powerful when it comes to just generalizing to, across these many different tasks. So prompts, which control those instructions, are a fundamental part of that. Now, LangChain naturally has many functionalities around prompts, and we can build very dynamic prompting pipelines that modify the structure and content of what we're actually feeding into our LLM, depending on different variables, different inputs. And we'll see that in this chapter. So we're going to work through prompting within the scope of a RAG example. So let's start by just dissecting the various parts of a prompt that we might expect to see for a use case like RAG. So our typical prompt for RAG, or retrieval augmented generation, will include rules for the LLM, and this is this you will see in most prompts, if not all. This part of the prompt sets up the behavior of the LLM. That is how it should be responding to user queries, what sort of personality it should be taking on, what it should be focusing on when it is responding, any particular rules or boundaries that we want to set. And really what we're trying to do here is just to simply provide as much information as possible to the LLM about what we're doing. We just want to give the LLM context as to the place that it finds itself in, because an LLM has no idea where it is. It takes in some information and spits out information. If the only information it receives is from the user's user query, it has it doesn't know the context. What is the application that it is within? What is its objective? What is its aim? What are the boundaries? All of this we need to just assume the LLM has absolutely no idea about, because it truly does not. So as much context as we can provide, but it's important that we don't overdo it. We see this all the time. People will over prompt an LLM, you want to be concise. You don't want fluff. And in general, every single part of your prompt, the more concise and less fluffy you can make it, the better. Now, those rules or instructions are typically in the system prompt of your LLM. Now, the second one is context, which is RAG specific. The context refers to some sort of external information that you are feeding into your LLM. We may have received this information from like a web search, database query, or quite often in this case of RAG, it's a vector database. This external information that we provide is essentially the RA, retrieval augmentation, of RAG. We are augmenting the knowledge of our LLM, which the knowledge of our LLM is contained within the LLM model weights. We're augmenting that knowledge with some external knowledge. That's what we're doing here. Now, for chat LLMs, this context is typically placed within a conversational context within the user or assistant messages. And with more recent models, it can also be placed within tool messages as well. Then we have the question. It's pretty straightforward. This is the query from the user. This is, well, it's usually a user message, of course. There might be some additional formatting around this. You might add a little bit of extra context, or you might add some additional instructions if you find that your LLM sometimes veers off the rules that you've set within the system prompt. You might, append or prefix something here, but for the most part, it's probably just going to be the user's input. And then finally, so these are all the inputs for our prompt. Here is going to be the output that we get, so the answer from the assistant. Again, I mean, that's not even specific to RAG, it's just what you would expect in a chat LLM or any LLM. And of course, that would be an assistant message. So putting all of that together in an actual prompt, so you can see everything we have here. So we have the rules for our prompt here, the instructions. We're just saying, okay, answer the question based on the context below. If you cannot answer the question using the information, answer with I don't know. Then we have some context here. Okay, in this scenario, that context that we're feeding in here, because it's the first message, we might be putting that into the system prompt, but that may also be turned around. Okay, if you for example have an agent, you might have your question up here before the context, and then that would be coming from a user message, and then this context would follow the question and be recognized as a tool message, and it would be fed in that way as well. Kind of depends on what sort of structure you're going for there, but you can do either. You can feed it into the system message if it's less conversational, whereas if it's more conversational, you might feed it in as a tool message. Okay, and then we have a user query, which is here, and then we'd have the AI answer. Okay, and obviously that would be generated here. Okay, so let's switch across to the code. We're in the LangChain course repo, notebooks 03 prompts. I'm just going to open this in Colab. Okay, let's scroll down and we'll start just by installing the prerequisites. Okay, so we just have the various libraries again. As I mentioned before, Langsmith is optional. You don't need to install it, but if you would like to see your traces and everything in Langsmith, then I would recommend doing that. And if you are using Langsmith, you will need to enter your API key here. Again, if you're not using Langsmith, you don't need to enter anything here. You just skip that cell. Okay, cool. And let's jump into the basic prompting then. So we're going to start with this prompt. Answer the user query based on the question below. So we're just structuring what we just saw in code. And we're going to be using the chat prompt template because generally speaking, we're using chat LLMs in most cases nowadays. So we have our chat prompt template, and that is going to contain a list of messages, system message to begin with, which is just going to contain this, and we're feeding in the context within that there. And we have our user query here, okay? So we'll run this, and if we take a look here, we haven't specified what our input variables are, okay? But we can see that we have query and we have context up here, right? So we can see that, okay, these are the input variables. We just haven't explicitly define them here. So let's just confirm with this that LangChain did pick those up, and we can see that it did. So it has context and query as our input variables for the prompt template that we just defined. Okay, so we can also see the structure of our templates. Let's have a look. Okay, so we can see that within messages here, we have a system message prompt template. The way that we define this, you can see here that we have from messages, and this will consume various different structures. So you can see here that it has from messages, it is a sequence of message-like representation. So we could pass in a system prompt template object and then a user prompt template object, or we can just use a tuple like this, and this actually defines, okay, this is system, this is a user, and you could also do assistant or tool messages and stuff here as well using the same structure. And then we can look in here, and of course that is being translated into the system message prompt template and human message prompt template. Okay, we have our input variables in there and there, and we have the template too. Okay, now let's continue. We'll see here what I just said. So we're importing our system message prompt template and human message prompt template. And you can see we're using the same from messages method here, right? And you can see it's still sequence of message-like representation. It's just that, what that actually means, it can vary, right? So here we have system message prompt template, from template, prompt. Here, from template, query. There's various ways that you might want to do this. It just depends on how explicit you want to be. Generally speaking, I think for myself, I would prefer that we stick with the objects themselves and be explicit, but it is definitely a little harder to parse when you're reading this. So I understand why you might also prefer this. It's definitely cleaner, and it does look simpler. So it just depends, I suppose, on preference. Okay, so you can see again that this is exactly the same. Okay, we have chat prompt template, and it contains this and this. Okay, you probably want to see the exact output. So it was messages. Okay, exactly the same as what I output before. Cool, so we have all of that. Let's see how we would invoke our LLM with these. We're going to be using 4.0 mini again. We do need our OpenAI API key, so enter that. And we'll just initialize our LLM. We are going with a low temperature here, so less randomness or less creativity. And in many cases, this is actually what I would be doing. The reason in this scenario that we're going with low temperature is we're doing RAG. And if you remember before, if we scroll up a little bit here, our template says, answer the user's query based on the context below. If you cannot answer the question using the provided answer information, answer with I don't know, right? So just from reading that, we know that we want our LLM to be as truthful and accurate as possible. So a more creative LLM is going to struggle with that and is more likely to hallucinate. Whereas a low creativity or low temperature LLM will probably stick with the rules a little better. So again, it depends on your use case. If you're creative writing, you might want to go with a higher temperature there. But for things like RAG, where the information being output should be accurate and truthful, it's important, I think, that we keep temperature low. Okay, I talk about that a little bit here. So of course, lower temperature of 0 makes the LLM's output more deterministic, which in theory should lead to less hallucination. Okay, so we're going to go with LCell again here. This is, for those of you that use LangChain in the past, this is equivalent to an LLM chain object. So our prompt template is being fed into our LLM. Okay, and from now we have this pipeline. Now let's see how we would use that pipeline. So we're going to get create some context here. So this is just some context around Aurelio AI. Mention that we built semantic routers, semantic chunkers. There's AI platform and development services. We mentioned, I think we specifically outline this later on in the example. So the LangChain experts, a little piece of information. Now, most LLMs would have not been trained on the recent internet. So the fact that this came in September 2024 is relatively recent. So a lot of LLMs out of the box, you wouldn't expect them to know that. So that is a good little bit of information to ask about. So we invoke, we have our query. So what do we do? And we have that context. Okay, so we're feeding that into that pipeline that we defined here. All right, so when we invoke that is automatically going to take query and context and actually feed it into our prompt template. Okay. If we want to, we can also be a little more explicit. So that you will probably see me doing this throughout the course, because I do like to be explicit with everything, to be honest. And you'll probably see me doing this. Okay, and this is doing the same thing. Well, you'll see it will in a moment. This is doing the exact same thing. Again, this is just an LSL thing. So all I'm doing in this scenario is I'm saying, okay, take from the dictionary query, and then also take from that input dictionary the context key. Okay, so this is doing the exact same thing. The reason that we might want to write this is mainly for clarity, to be honest, just to explicitly say, okay, these are the inputs, because otherwise we don't really have them in the code other than within our original prompts up here, which is not super clear. So I think it's usually a good idea to just be more explicit with these things. And of course, if you decide you're going to modify things a little bit, let's say you modify this to input down the line, you can still feed in the same input here. You just mapping it between different keys essentially. Or if you would like to just modify that, I don't know, you need to lowercase it on the way in or something, you can do. So you have that. I'll just redefine that actually, and we'll invoke again. Okay, and we see that it does the exact same thing. Okay, so Aurelio AI, so this is a AI message just generated by the LLM. Okay, expertise in building AI agents, several open source frameworks, router, AI platform, okay, right? So provide development, so they have everything there. Other than the LangChain experts thing, it didn't mention that, but we will, we'll test it later on that. Okay, so on to few-shot prompting. This is a specific prompting technique. Now, many sort of state-of-the-art or SOTA LLMs are very good at instruction following. So you'll find that few-shot prompting is less common now than it used to be, at least for the sort of bigger, more state-of-the-art models. But when you start using smaller models, not really what we can use here, but let's say you're using a open source model like Llama 3 or Llama 2, which is much smaller, you will probably need to consider things like few-shot prompting. Although that being said, with OpenAI models, at least the current OpenAI models, this is not so important. Nonetheless, it can be useful. So the idea behind few-shot prompting is that you are providing a few examples to your LLM of how it should behave before you are actually going into the main part of the conversation. So let's see how that would look. So we create an example prompt. So we have our human and AI. So human input, AI response. So we're basically setting up, okay, with this type of input, you should provide this type of output. That's what we're doing here. And we're just going to provide some examples. Okay, so we have our input. Here's query 1. Here is the answer 1. All right, this is just, I just want to show you how it works. This is not what we'd actually feed into our LLM. Then, with both these examples and our example prompt, we'd feed both of these into LangChain's few-shot chat message prompt template. Okay, and well, you'll see what we get out of it. Okay, so we basically it formats everything and structures everything for us. Okay, and using this, of course, it depends on, let's say you see that your user is talking about a particular topic and you would like to guide your LLM to talk about that particular topic in a particular way, right? So you could identify that the user is talking about that topic, either like a keyword match or a semantic similarity match. And based on that, you might want to modify these examples that you feed into your few-shot chat message prompt template. And then obviously that could be what you do for topic A. For topic B, you might have another set of examples that you feed into this. All this time, your example prompt is remaining the same, but you're just modifying the examples that are going in so that they're more relevant to whatever it is your user is actually talking about. So that can be useful. Now let's see an example of that. So when we are using a TinyLM, its ability would be limited, although I think we're probably fine here. We're going to say, answer the user query based on the context below, always answer in Markdown format, being very specific. This is our system prompt. Okay, that's nice. But what we've kind of said here is, okay, always answer in Markdown format. It did do that. But when doing so, please provide headers, short summaries, and follow bullet points, then conclude. Okay, so you see this here. Okay, so we get this overview of already. You have this and this. It's actually quite good. But if we come down here, what I specifically want is to always follow this structure. Right, so we have the double header for the topic, summary, a header, a couple of bullet points, and then I always want to follow this pattern where it's like to conclude. It's always bold. I want to be very specific on what I want, and to be fully honest with GPT-4o Mini, you can actually just prompt most of this in. But for the sake of the example, we're going to provide few-shot examples in our few-shot prompt examples instead to get this. So we're going to provide one example here, second example here, and you'll see we're just following that same pattern. We're just setting up the pattern that the LLM should use. So we're going to set that up here. We have our main header, a little summary, some subheaders, bullet points, subheader, bullet points, subheader, bullet points, to conclude, so on and so on. Same with this one here. Okay. And let's see what we got. Okay. So this is the structure of our new few-shot prompt template. You can see what all of this looks like. Let's come down and we're basically going to insert that directly into our chat prompt template. So we have from messages, system prompt, user prompt, and then we have in there these. So let me actually show you very quickly. Right, so we just have this few-shot chat to message prompt template, which will be fed into the middle here. Run that, and then feed all this back into our pipeline. Okay, and this will modify the structure so that we have that bold to conclude at the end here. Okay, we can see it nicely here. So we get a bit more of that, the exact structure that we were getting. Again, with GPT-4o models and many other OpenAI models, you don't really need to do this, but you will see it in other examples. We do have an example of this where we're using Ollama, and we're using, I think, Llama 2, if I'm not wrong. And you can see that adding this few-shot prompt template is actually a very good way of getting those smaller, less capable models to follow your instructions. So this is really, when you're working those small LLMs, this can be super useful. But even for SOTA models like GPT-4o, if you do find that you're struggling with the prompting, it's just not quite following exactly what you want it to do, this is a very good technique for actually getting it to follow a very strict structure or behavior. Okay, so moving on, we have chain of thought prompting. So this is a more common prompting technique that encourages the LM to think through its reasoning or its thoughts step by step. So it's a chain of thought. The idea behind this is that, in math class, when you're a kid, the teachers would always push you to put down your working out, right? And there's multiple reasons for that. One of them is to get you to think, because they know in a lot of cases, actually, you're a kid and you're in a rush and you don't really care about this test. And they're just trying to get you to slow down a little bit and actually put down your reasoning. And that kind of forces you to think, oh, actually, I'm skipping a little bit in my head because I'm trying to just do everything up here. If I write it down, all of a sudden it's like, oh, actually, I need to actually do that slightly differently. You realize, okay, you're probably rushing a little bit. Now, I'm not saying an LLM is rushing, but it's a similar effect. By an LLM writing everything down, they tend to actually get things right more frequently. And at the same time, also similar to when you're a child and a teacher is reviewing your exam work, by having the LLM write down its reasoning, you as a human or engineer, you can see where the LLM went wrong if it did go wrong, which can be very useful when you're trying to diagnose problems. So with train of thought, we should see less hallucinations and generally better performance. Now, to implement chain of thought in LangChain, there's no specific like LangChain objects that do that. Instead, it's just prompting. Okay, so let's go down and just see how we might do that. Okay, so be a helpful assistant and answer the user's question. You must answer the question directly without any other text or explanation. Okay, so that's our no chain of thought system prompt. I will just note here, especially with OpenAI, again, this is one of those things where you'll see it more with the smaller models. Most LLMs are actually trained to use chain of thought prompting by default. So we're actually specifically telling it here, you must answer the question directly without any other text or explanation. Okay, so we're actually kind of reverse prompting it to not use chain of thought. Otherwise, by default, it actually will try and do that because it's been trained to. That's how relevant chain of thought is. Okay, so I'm going to say how many keystrokes I need to type in. Type the numbers from 1 to 500. Okay, we set up our like LLM chain pipeline, and we're going to just invoke our query, and we'll see what we get. Total number of keystrokes needed to type the numbers from 1 to 500 is 1,511. The actual answers I've written here is 1,392. Without chain of thought, it's hallucinating. Okay, now let's go ahead and see, okay, with chain of thought prompting, what does it do? So be a helpful assistant and answer the user's question. To answer the question, you must list systematically and in precise detail all subproblems that are needed to be solved to answer the question. Solve each subproblem individually. You have to shout at the LLM sometimes to get them to listen, and in sequence. Finally, use everything you've worked through to provide a final answer. Okay, so we're forcing it to kind of go through the full prompt now. We can remove that. I'm not sure why it's there. So run that. Again, I don't know why we have context there. I'll remove that. And let's see. You can see straight away that's taking a lot longer to generate the output. That's because it's generating so many more tokens. So that's just one drawback of this, but let's see what we have. So to determine how many keystrokes to type those numbers, it's breaking it down into several subproblems. So count the number of digits from 1 to 9, 10 to 99, so on, and count the digits in number 500. Okay, interesting. So that's how it's breaking it up. Some more digits counted in the previous steps. So we go through total digits and we see that's, okay, 9 digits for those. For here, 180. For here, 1,200. And then, of course, 3 here. So it gets all those, it sums those digits and actually comes to the right answer. Okay, so that is, that's the difference with chain of thought versus without. So without it, we just get the wrong answer, basically guessing. With chain of thought, we get the right answer just by the LLM writing down its reasoning and breaking the problem down into multiple parts, which is, I found that super interesting that it does that. So that's pretty cool. Now I will just see, so as we mentioned before, most LLMs nowadays are actually trained to use chain of thought prompting by default. So let's just see if we don't mention anything, right? Be a helpful assistant and answer the user's question. So we're not telling it not to think through its reasoning, and we're not telling it to think through its reasoning. Let's just see what it does. Okay, so you can see, again, it's actually doing the exact same reasoning. Okay, it doesn't give us like the subproblems at the start, but it is going through and it's breaking everything apart. Okay, which is quite interesting. and we get the same correct answer. So the formatting here is slightly different. It's probably a little cleaner, actually, although I think, I don't know. Here we get a lot more information. So both are fine. And in this scenario, we actually do get the right answer as well. So you can see that that chain of thought prompting has actually been quite literally trained into the model. And you'll see that with most, well, I think all state-of-the-art LLMs. Okay, cool. So that is our chapter on prompting. Again, we're just focusing very much on a lot of the fundamentals of prompting there, and of course, tying that back to the actual objects and methods within LangChain. But for now, that's it for prompting, and we'll move on to the next chapter. In this chapter, we're going to be taking a look at conversational memory in LangChain. We're going to be taking a look at the core chat memory components that have already been in LangChain since the start, but are essentially no longer in the library. And we'll be seeing how we actually implement those historic conversational memory utilities in the new versions of LangChain, so 0.3. Now, as a pre-warning, this chapter is fairly long, but that is because conversational memory is just such a critical part of chatbots and agents. Conversational memory is what allows them to remember previous interactions, and without it, our chatbots and agents would just be responding to the most recent message without any understanding of previous interactions within a conversations. So they would just not be conversational. And depending on the type of conversation, we might want to go with various approaches to how we remember those interactions within a conversation. Now, throughout this chapter, we're going to be focusing on these 4 memory types. We'll be referring to these, and I'll be showing you actually how each one of these works. But what we're really focusing on is rewriting these for the latest version of LangChain using what's called the runnable with message history. So we're going to be essentially taking a look at the original implementations for each of these 4 original memory types, and then we'll be rewriting them with the runnable memory history class. So just taking a look at each of these 4 very quickly. Conversational buffer memory is, I think, the simplest and most intuitive of these memory types. It is literally just you have your messages, they come into this object, they are stored in this object as essentially a list, and when you need them again, it will return them to you. There's nothing else to it. It's super simple. The conversation buffer window memory, okay, so new word in the middle there, window. This works in pretty much the same way, but those messages that it has stored, it's not going to return all of them for you. Instead, it's just going to return the most recent, let's say the most recent 3, for example. Okay, and that is defined by a parameter k. Conversational summary memory, rather than keeping track of the entire interaction memory directly, what it's doing is as those interactions come in, it's actually going to take them and it's going to compress them into a smaller little summary of what has been within that conversation. And as a new interaction is coming in, it's going to do that, going to keep iterating on that summary. And then that is going to be returned to us when we need it. And finally, we have the conversational summary buffer memory. So this is, so the buffer part of this is actually referring to a very similar thing to the buffer window memory, but rather than it being a most k messages, it's looking at the number of tokens within your memory, and it's returning the most recent k tokens. That's what the buffer part is there. And then it's also merging that with the summary memory here. So essentially what you're getting is almost like a list of the most recent messages based on the token length rather than the number of interactions, plus a summary, which would come at the top here. So you get kind of both. The idea is that obviously this summary here would maintain all of your interactions in a very compressed form. So you're you're losing less information and you're still maintaining, maybe the very first interaction, the user might have introduced themselves, giving you their name. Hopefully that would be maintained within the summary and it would not be lost. And then you have almost like a higher resolution on the most recent K or K tokens from your memory. Okay, so let's jump over to the code. We're going into the 04 chat memory notebook, open that in Colab. Okay, now here we are. Let's go ahead and install the prerequisites, run all. We, again, can or cannot use AlignSmith. It is up to you. Enter that, and let's come down and start. So first, to just initialize our LLM using 4.0 mini. In this example, again, low temperature. And we're going to start with conversation buffer memory. Okay, so this is the original version of this memory type. So let me, where are we? We're here. So memory, conversation buffer memory, and we're returning messages that needs to be set to true. So the reason that we set return messages to true, as it mentions up here, is if you do not do this, it's going to be returning your chat history as a string to an LLM, whereas, well, chat LLMs nowadays would expect message objects. So yeah, you just want to be returning these as messages rather than as strings. Okay. Otherwise, yeah, you're going to get some kind of strange behavior out from your LLMs if you return them as strings. So you do want to make sure that it's true. I think by default, it might not be true, but this is coming. This is deprecated, right? It does tell you here as a deprecation warning. This is coming from older LangChain, but it's a good place to start just to understand this. And then we're going to rewrite this with the runnables, which is the recommended way of doing so nowadays. Okay. So adding messages to our memory. We're going to write this. Okay, so it's just a conversation, user AI, so on and so on. Random chat. Main things to note here is I do provide my name. We have the model's name, right, towards the start of those interactions. Okay, so I'm just going to add all of those. We'll do it like this. Okay, then we can just see, we can load our history like so. So let's just see what we have there. Okay, so we have a human message, AI message, human message, right? This is exactly what I showed you just here. It's just in that message format from LangChain. Okay, so we can do that. Alternatively, we can actually do this. So we can get our memory. We initialize the conversational buffer memory as we did before, and we can actually add it directly, each message, into our memory like that. So we can use this add user message, add AI message, so on and so on, load again, and it's going to give us the exact same thing. Again, there's multiple ways to do the same thing. Cool. So we have that. To pass all of this into our LLM, again, this is all deprecated stuff. We're going to learn how to use properly in a moment, but this is how LangChain was doing it in the past. So to pass all of this into our LLM, we'd be using this conversation chain, right? Again, this is deprecated. Nowadays, we would be using LCell for this. So I just want to show you, okay, how this would all go together. And then we would invoke, okay, what is my name again? Let's run that and we'll see what we get. It's remembering everything, remember? So this conversation buffer memory, it doesn't drop messages. It just remembers everything, right? And honestly, with the sort of high context windows of many LLMs, that might be what you do. It depends on how long you expect a conversation to go on for, but you probably, in most cases, would get away with this. Okay, so let's see what we get. I say, what is my name again? Okay, let's see what it gives me. It says your name is James. Great, thank you. That works. Now, as I mentioned, all of this that I just showed you is actually deprecated. That's the old way of doing things. Let's see how we actually do this in modern or up-to-date LangChain. So we're going to be using this runnable with message history. To implement that, we will need to use LCell. And for that, we will need to just define prompt templates, our LLM, as we usually would. Okay, so we're going to set up our system prompt, which is just your helpful assistant called Zeta. Okay, we're going to put in this messages placeholder. Okay, so that's important. Essentially, that is where our messages are coming from. Our conversation buffer memory is going to be inserted, right? So it's going to be That chat history is going to be inserted after our system prompt, but before our most recent query, which is going to be inserted last here. Okay, so messages, placeholder item, that's important. And we use that throughout the course as well. So we use it both for chat history, and we'll see later on, we also use it for the intermediate thoughts that a agent would go through as well. So important to remember that little thing. We'll link our prompt template to our LLM. Again, if we would like, we could also add in I think we only have the query here. Oh, we would probably also want our history as well, but I'm not going to do that right now. Okay, so we have our pipeline, and we can go ahead and actually define our runnable with message history. Now, this class or object, when we are initializing it, does require a few items. We can see them here. Okay, so we see that we have our pipeline with history. So it's basically going to be, you can see here, right? We have that history messages key, right? This here has to align with what we provided as the messages placeholder in our pipeline, right? So we have our pipeline prompt template here and here, right? So that's where it's coming from. It's coming from messages placeholder. The variable name is history, right? That's important. That links to this. Then for the input messages key here, we have query. That, again, links to this. Okay, so both important to have there. The other thing that is important is obviously we're passing in that pipeline from before, but then we also have this get session history. Basically what this is doing is it's saying, okay, I need to get the list of messages that make up my chat history that are going to be inserted into this variable. So that is a function that we define. Okay, and within this function, what we're trying to do here is actually replicate what we have with the previous conversation buffer memory. Okay, so that's what we're doing here. So it's very simple, right? So we have this in-memory chat message history. Okay, so that's just the object that we're going to be returning. What this will do is it will set up a session ID. The session ID is essentially like a unique identifier so that each conversation or interaction within a single conversation is being mapped to a specific conversation. So you don't have overlapping. Let's say you have multiple users using the same system. You want to have a unique session ID for each one of those. Okay. And what it's doing is saying, okay, if the session ID is not in the chat map, which is this empty dictionary we defined here, we are going to initialize that session with an in-memory chat message history. Okay. And that's it. And we return. Okay, and all that's going to do is it's going to basically append our messages. They will be appended within this chat map session ID, and they're going to get returned. There's nothing else to it, to be honest. So we invoke our runnable. Let's see what we get. Oh, I need to run this. Okay, note that we do have this config, so we have a session ID. That's to, again, as I mentioned, keep different conversations separate. Okay, so we've run that. Now let's run a few more. So what is my name again? Let's see if it remembers. Your name is James. How can I help you today, James? Okay, so it's what we've just done there is literally conversation buffer memory, but for up-to-date LangChain with LCell with runnables. So the recommended way of doing it nowadays. So that's a very simple example. Okay, there's really not that much to it. It gets a little more complicated as we start thinking about the different types of memory. Although with that being said, it's not massively complicated. We're only really going to be changing the way that we're getting our interactions. So let's dive into that and see how we will do something similar with the conversation buffer window memory. But first, let's actually just understand, okay, what is the conversation buffer window memory? So as I mentioned near the start, it's going to keep track of the last K messages. So there's a few things to keep in mind here. More messages does mean more tokens sent with each request. And if we have more tokens in each request, it means that we're increasing the latency of our responses and also the cost. So with the previous memory type, we're just sending everything. And because we're sending everything, that is going to be increasing our costs, it's going to be increasing our latency for every message, especially as the conversation gets longer and longer. And we might not necessarily want to do that. So with this conversation buffer window memory, we're going to just say, okay, just return me the most recent messages. Okay, so let's see how that would work. Here, we're going to return the most recent 4 messages. Okay, we are, again, make sure we return messages is set to true. Again, this is deprecated. This is just the old way of doing it. In a moment, we'll see the updated way of doing this. We'll add all of our messages. Okay, so we have this, and just see here, right? So we've added in all these messages. There's more than 4 messages here, and we can actually see that here. So we have human message, AI, human, AI, human, AI, human, AI, right? So we've got 4 pairs of human AI interactions there. But here we don't have, there's more than 4 pairs. So 4 pairs would take us back all the way to here. I'm researching different types of conversational memory. Okay, and if we take a look here, the first message we have is I'm researching different types of conversational memory. So it's cut off these 2 here, which will be a bit problematic when we ask you what our name is. Okay, so let's just see. We're going to be using conversation chain object again. Again, just remember that is deprecated. And I want to say, what is my name again? Let's see what it says. I'm sorry, but I don't have access to your name or any personal information. If you like, you can tell me your name, right? So it doesn't actually remember. So that's kind of like a negative of the conversation buffer window memory. Of course, to fix that in this scenario, we might just want to increase K. Maybe we say, remember the previous 8 interaction pairs, and it will actually remember. So what is my name again? Your name is James. So now it remembers. We've just modified how much it is remembering. But of course, there's pros and cons to this. It really depends on what you're trying to build. So let's take a look at how we would actually implement this with the runnable with message history. Okay, so getting a little more complicated here, although it's not complicated, but well, we'll see. Okay, so we have a buffer window message history. We're creating a class here. This class is going to inherit from the base chat message history object from LangChain. Okay, and all of our other message history objects can do the same thing. Before, with the in-memory message object, that was basically replicating the buffer memory. So we didn't actually need to do anything. We didn't need to define our own class here. So in this case, we do. So we follow the same pattern that LangChain follows with this base chat message history. And you can see a few of the functions here that are important. So add messages and clear are the ones that we're going to be focusing on. We also need to have messages, which is this object attribute here. Okay, so we're just implementing the synchronous methods here. If we want this to be async, if we want to support async, we would have to add messages, a get messages, and a clear as well. So let's go ahead and do that. We have messages, we have K. Again, we're looking at remembering the top K messages or most recent K messages only. So it's important that we have that variable. We are adding messages through this class. This is going to be used by LangChain within our runnable. So we need to make sure that we do have this method. And all we're going to be doing is extending the self messages list here. And then we're actually just going to be trimming that down so that we're not remembering anything beyond those most recent K messages that we have set from here. And then we also have the clear method as well. So we need to include that. That's just going to clear the history. Okay. So this isn't complicated, right? It just gives us this nice default standard interface for message history. And we just need to make sure we're following that pattern. Okay. I've included this print here just so we can see what's happening. Okay. So we have that. And now for that get chat history function that we defined earlier, rather than using the built-in method, we're going to be using our own object, which is a buffer window message history, which we defined just here. Okay. So if session ID is not in the chat map as we did before, we're going to be initializing our buffer window message history. We're setting K up here with a default value of 4, and then we just return it. Okay. And that is it. So let's run this. We have our runnable with message history. We have all of these variables, which are exactly the same as before, but then we also have these variables here with this history, factory, config. And this is where if we have new variables that we've added to our message history, in this case, K that we have down here, we need to provide that to LangChain and tell it this is a new configurable field. Okay. And we've also added it for the session ID here as well. So we're just being explicit and have everything in there. So we have that and we run. Okay. Now let's go ahead and invoke and see what we get. Okay. So important here, this history factory config, that is kind of being fed through into our invoke so that we can actually modify those variables from here. Okay. So we have config, configurable, session ID. Okay. We'll just put whatever we want in here. And then we also have the number K. Okay. So remember the previous 4 interactions. I think in this one, we're doing something slightly different. I think we're remembering the 4 interactions rather than the previous 4 interaction pairs. Okay, so my name is James. We're going to go through, I'm just going to actually clear this and then I'm going to start again. And we're going to use the exact same add user message, add AI message that we used before. We're just manually inserting all that into our history so that we can then just see, okay, what is the result? And you can see that K equals 4 is actually, unlike before where we were having the, saving the top 4 interaction pairs, we're now saving the most recent 4 interactions, not pairs, just interactions. And honestly, I just think that's clearer. I think it's weird that the number 4 for K would actually save the most recent 8 messages, right? I think that's odd. So I'm just not replicating that weirdness. We could if we wanted to. I just don't like it. So I'm not doing that. And anyway, we can see from messages that we're returning just the most 4 recent messages, okay? Which would be these 4. Okay, cool. So we've just, using the runnable, we've replicated the old way of having a window memory. And okay, I'm going to say, what is my name again? As before, it's not going to remember. So we can come to here. I'm sorry about that access to personal information, and so on and so on. If you like to tell me your name, it doesn't know. Now let's try a new one where we initialize a new session. Okay, so we're going with ID K14, so that's going to create a new conversation there. And we're going to say, we're going to set K to 14. Okay, great. I'm going to manually insert the other messages as we did before. Okay, and we can see all of those. You can see at the top here, we are still maintaining that, hi, my name is James message. Now let's see if it remembers my name. Your name is James. Okay, there we go. Cool, so that is working. We can also see, so we just added this. What is my name again? Let's just see if, did that get added to our list of messages, right? What is my name again? Nice. And then we also have the response, your name is James. So just by invoking this, because we're using the runnable with message history, it's just automatically adding all of that into our message history, which is nice. Cool. All right, so that is the buffer window memory. Now we are going to take a look at how we might do something a little more complicated, which is the summaries, okay? So when you think about the summary, what are we doing? We're actually taking the messages, we're using the LLM call to summarize them, to compress them, and then we're storing them within messages. So let's see how we would actually do that. So to start with, let's just see how it was done in old LangChain. So you have conversation summary memory. Go through that. And let's just see what we get. So again, same interactions, right? I'm just invoking. I'm not adding these directly to the messages because it actually needs to go through a, like that summarization process. And if we have a look, we can see it happening. Okay, current conversation. So, sorry, current conversation. Hello there, my name is James. AI is generating. Current conversation. The human introduces himself as James. AI greets James warmly and expresses its readiness to chat and assist, inquiring about how his day is going. Right, so it's summarizing the previous interactions. And then we have, after that summary, we have the most recent human message, and then the AI is going to generate its response. Okay, and that continues going. And you see that the final summary here is going to be a lot longer. Okay, and it's different to that first summary, of course. Asking about his day, he mentions that he's researching different types of conversational memory. The AI responds enthusiastically, explaining that conversational memory includes short-term memory, long-term memory, contextual memory, personalized memory, and then inquires if James is focused on a specific type of memory. Okay, cool. So we get essentially the summary is just getting longer and longer as we go. But at some point, the idea is that it's not going to keep just growing, and it should actually be shorter than if you were saving every single interaction whilst maintaining as much of the information as possible. But of course, you're not going to maintain all of the information that you would with, for example, the buffer memory, right? With the summary, you are going to lose information, but hopefully less information than if you were just cutting interactions. So you're trying to reduce your token count whilst maintaining as much information as possible. Now, let's go and ask, what is my name again? It should be able to answer because we can see in the summary here that I introduced myself as James. Okay, response, your name's James. How is your research going? Okay, so has that. Cool, let's see how we'd implement that. So again, as before, we're going to go with that conversation summary message history. We're going to be importing a system message. We're going to be using that not for the LLM that we're chatting with, but for the LLM that will be generating our summary. So actually, that is not quite correct. There's create a summary. Not that it matters, it's just the doc string. So we have our messages and we also have the LLM. So different attribute here to what we had before. When we initialize the conversation summary message history, we need to be passing in our LLM. We have the same methods as before. We have add messages and clear. And what we're doing is as messages come in, we extend with our current messages, but then we're modifying those. Okay, so we construct our instructions to make a summary. Okay, so that is here. We have the system prompt, given the existing conversation summary and the new messages, generate a new summary of the conversation, ensuring to maintain as much relevant information as possible. Okay, then we have a human message here. Through that, we're passing the existing summary. Okay, and then we're passing in the new messages. Okay, cool. So we format those and invoke the LLM here. And then what we're doing is in the messages, we're actually replacing the existing history that we had before with a new history, which is just a single system summary message. Okay, let's see what we get. As before, we have that get chat history exactly the same as before. The only real difference is that we're passing in the LLM parameter here. And of course, as we're passing in the LLM parameter in here, it does also mean that we're going to have to include that in the configurable field spec. And that we're going to need to include that when we're invoking our pipeline. Okay, so we run that, passing in the LLM. Now, of course, one side effect of generating summaries or everything is that we're actually, we're generating more. So you are actually using quite a lot of tokens. Whether or not you are saving tokens or not actually depends on the length of a conversation. As the conversation gets longer, if you're storing everything, after a little while, that the token usage is actually going to increase. So if in your use case, you expect to have shorter conversations, you would be saving money and tokens by just using the standard buffer memory. Whereas if you're expecting very long conversations, you would be saving tokens and money by using the summary history. Okay, so let's see what we got from there. We have a summary of the conversation. James introduced himself by saying, "Hi, my name is James." AI responded warmly, asking, "Hi, James." And interaction included details about token usage. Okay, so we actually included everything here, which we probably should not have done. Why did we do that? So in here, we're including all of the including all of the content from the messages. So I think maybe if we just do x.content for x in messages, that should resolve that. Okay, there we go. So we quickly fix that. So yeah, before we were passing in the entire message object, which obviously includes all of this information, whereas actually we just want to be passing in the content. So we modified that, and now we're getting what we'd expect. Okay, cool. And then we can keep going, right? So as we keep going, the summary should get more like abstract. Like as we just saw here, is literally just giving us the messages directly almost. Okay, so we're getting a bit of a summary there, and we can keep going. We're going to add just more messages to that. We'll see the, as we'll send those, we'll get a response, send it again, get a response. And we're just adding all of that, invoking all of that, and that will be, of course, adding everything into our message history. Okay, cool. So we've run that. Let's see what the latest summary is. Okay, and then we have this. So this is a summary that we have instead of our chat history. Okay, cool. Now, finally, let's see what's my name again. We can just double check. It has my name in there, so it should be able to tell us. Okay, cool. So your name is James. Pretty interesting. So let's have a quick look over at Langsmith. So the reason I want to do this is just to point out, okay, the different essentially token usage that we're getting with each one of these. Okay, so we can see that we have these runnable message history, which are probably improved in naming there. But we can see, okay, how long is each one of these taken? How many tokens are they also using? Come back to here. We have this runnable message history. This is, we'll go through a few of these, maybe to here, I think. And we can see here, this is that first interaction where we're using the buffer memory. And we can see how many tokens we use here. So 112 tokens when we're asking, what is my name again? Okay. Then we modified this to include, I think it was like 14 interactions or something along those lines. It obviously increases the number of tokens that we're using, right? So we could see that actually happening all in Langsmith, which is quite nice. And we can compare, okay, how many tokens is each one of these using? Now, this is looking at the buffer window. And then if we come down to here and look at this one, so this is using our summary. Okay, so our summary with what is my name again, actually use more tokens in this scenario, right? Which is interesting because we're trying to compress information. The reason there's more is because there hasn't been that many interactions. As the conversation length increases with the summary, this total number of tokens, especially if we prompt it correctly to keep that low, that should remain relatively small. Whereas with the buffer memory, that will just keep increasing and increasing as the conversation gets longer. So useful little way of using Langsmith there to just kind of figure out, okay, in terms of tokens and costs, what we're looking at for each of these memory types. Okay, so our final memory type acts as a mix of the summary memory and the buffer memory. So what it's going to do is keep the buffer up until an n number of tokens. And then once a message exceeds the n number of token limit for the buffer, it is actually going to be added into our summary. So this memory has the benefit of remembering in detail the most recent interactions, whilst also not having the limitation of using too many tokens as a conversation gets longer, and even potentially exceeding context windows if you try super hard. So this is a very interesting approach. Now, as before, let's try the original way of implementing this. Then we will go ahead and use our update method for implementing this. So we come down to here, and we're going to do LangChain memory import conversation summary buffer memory. Okay, a few things here. LLM for summary. We have the n number of tokens that we can keep before they get added to the summary, and then return messages, of course. Okay, you can see again, this is deprecated. We use the conversation chain, and then we just pass in our memory there, and then we can chat. Okay, so super straightforward. First message. We'll add a few more here. Again, we have to invoke because our memory type here is using an LLM to create those summaries as it goes. And let's see what they look like. Okay, so we can see for the first message here, we have a human message, and then an AI message. Then we come a little bit lower down. Again, it's the same thing. Human message is the first thing in our history here. Then it's a system message. So this is at the point where we've exceeded that 300 token limit, and the memory type here is generating those summaries. So that summary comes in as a system message. And we can see, okay, the human named James introduces himself and mentions he's researching different types of conversational memory, and so on and so on, right? Okay, cool. So we have that. Then let's come down a little bit further. We can see, okay, so the summary there. Okay, so that's what we